We're going to continue our work looking at De Moivre's theorem to prove trig identities, and this directly follows on from the last and the one before, so having an understanding of those is key, because this is going to take a bit of work to get through, but we'll have a go at it. We're asked to show that 32 cosine to the power of 6 theta is cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10, and in B, hence find the integral from 0 to pi by 6 of cos to the 6 theta d theta in the form a pi plus b root 3, where a and b are constants. So if that makes no sense, please watch the videos before us. I'm going to go through it fairly quickly. So what we already know then is z plus 1 over z is equal to 2 cos theta, and in general z to the n plus 1 over z to the n is equal to 2 cos n theta. We're going to use the binomial expansion on this. First, what we're going to do now is set this up, and we're going to say the following. We're going to say 2 cos theta all to the power of 6 is going to be equal now to z plus 1 over z to the power of 6. So this is going to give me now 64 cos to the 6 theta is going to be equal to the expansion of z plus 1 over z to the power of 6. So we need to use binomial expansion. We need the coefficients when we're looking at powers of 6. They're going to be 1, 6, 15, 20. Then what are we going to have? We're going to have, from there, we're going to have 15, 6, and 1. That looks good. Yeah, they work. So let's work with those then. So let's start off then. What we're going to have, and this is going to be pretty messy, we're going to have z to the 6 plus 6 z to the 5th, and then we're going to have 1 over z. Then we're going to have plus 15 z to the 4th, then we're going to have 1 over z squared, plus 20, we're going to get z cubed plus, z cubed multiplied by 1 over z cubed. Then we're going to get plus, and this is going to be 15 z squared, and then 1 over z to the 4th. Then we're going to get plus 6, and we're going to get z, we're going to get 1 over z to the 5th, and finally 1 over z to the 6th. So if that has gone completely over your head, we looked at this in the last video. So let's collect them up. Z to the 6 plus 1 over z to the 6. So let's now write this. That 64 cos to the 6 theta is going to be z to the 6 plus 1 over z to the 6. Okay, so z to the 6 plus 1 over z to the 6. We've now got this one right here, and that's going to be z to the 4th, and we've got 1 over z to the 4th here. So we end up now with plus 6 lots of z to the 4th plus 1 over z to the 4th. Let's now look at this one. This is going to give me z squared, and we're going to have 1 over z squared. So we've got plus 15 z squared plus 1 over z squared. And then our final term will give us a constant z to the 3rd multiplied by 1 over z to the 3rd multiplied by 20 is simply going to give us plus 20. Okay, those cancel out. We know from this part right here that z to the n plus 1 over z to the n is 2 cos n theta. So what we can now say is 64 cos to the 6 theta is going to be now equal to 2 cos, and this is going to be 6 theta, just match that up there, 2 cos 6 theta plus 6 lots of 2 cos 4 theta, which is going to give us 12 cos 4 theta. And then what we're going to have now is 2 cos 2 theta, 15 lots of that will give us plus 30 cos 2 theta plus our 20. So now let's tidy this up. We can factor this one. So what we got is 2 cos 6 theta plus 12 cos 4 theta plus 30 cos 2 theta plus 20. So highest common factor from that, we can't take 4 out, so we'll take 2 out. So what we've got now is the following. We've got 2 cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10. And now we know that that is equal to 64 cos to the 6 theta. So we can now say that cos to the 6 theta is going to be equal, dividing through by the 64, 1 over 32, the quantity cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta, and then we'll have plus 10. Right, hopefully that's what they wanted. There we go, that'll do. So we need to show that. We've shown that. Oh, we didn't even need to show it was just cos. I kind of got carried away. So what did we need to show? That it was 32 cos theta. Yeah, so this is essentially what it is. I've just divided both sides by 32. So we need to show it's cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10. Okay, so what we now need on this bit then is to find the integral. Okay, we need to find the integral from 0 to pi by 6 of cos to the 6 theta d theta. So if we think about it now, this is exactly what we're looking for. We're looking for the integral of this. So just consider the following. I can write this now as 1 over 32. Remember, this is a constant. The integral of this right here. So it's going to be the integral of cos 6 theta plus 6 cos 4 theta plus 15 cos 2 theta plus 10 d theta. So let's integrate that. We'll leave a constant outside, and we're going to be evaluating. So we've got 1 over 32. What are we evaluating from? Is it 0 to pi by 6? I think it's pi by 6. Or was it pi by 2? Let's check. Pi by 6. So now if we integrating cos 6 theta is going to give me 1 over 6 sine 6 theta. Integrating 6 cos 4 theta is going to give me now plus 6 over 4 or 3 over 2 sine 4 theta. Integrating now 15 cos 2 theta will give me plus 15 over 2 sine 2 theta. And integrating 10 with respect to theta is going to give me plus 10 theta. So all we need to do from here is simply evaluate, okay? So we need to evaluate from here. So if we look at it, if we feed through, and we'll have this here, 1 over 32, and then what we'll do, we'll start with the pi by 6. That's going to give me 0. If I put it in here, sine of pi is 0. We know the sine of pi is 0. If we think about the sine graph, sine of pi is going to be 0. So subbing in pi by 6 here is going to give me 0. If I now sub in this part right here, this is going to give me sine of 2 over 3 pi. So that one right there, if we think about that, subbing this in is going to give me 4 over 6 or 2 over 3. So sine of 2 pi by 3 is going to give me root 3 over 2. Okay, on a cast diagram or unit circle, that's over here somewhere. And we know that this is going to be 1, 2 and root 3. So this one now is going to give me plus 3 over 2 root 3 over 2. Now subbing it in here, what we're going to have is the following. We're going to have sine, and this is going to give me, if I get 2 lots of pi by 6, that's pi by 3, and again that gives me root 3 over 2. So what we've got this time now is plus 15 over 2 root 3 over 2, and then we've got now 10. Let's put that on. We got plus 10 theta. So if now I put in theta, theta is pi by 6. So this is going to give me, and we could write this now as 10 pi by 6 or plus, what's that going to be, 5 pi by 3. Okay. Now, if we think about the next one, subbing in 0, we're just going to get 0, we're going to get 0, we're going to get 0, and we're going to get 0. Nice. So let's tidy this little mess up. This is what we're asked to do. So we've got now 1 over 32. Now that's going to give me 3 root 3 over 4. That's going to give me 15 root 3 over 4, which is going to give me plus 18 root 3 over 4, which what can we do? We can make that 9 over 2, can't we? So we can make this now 9 over 2 root 3. And then what we've got then is this one right here, which is just for 5, so for 5 pi by 3. Okay, so what form do they want this in? A pi plus b root 3. So it looks like we're on the right track. So a pi, let's just write this here, a pi plus b root 3. So let's deal with the a pi first. If we multiply 1 over 32 by 5 pi by 3, we're going to get 5 pi by, what's that, 96? And now if we multiply this one here, we're going to get plus 9 root 3 over 64. So there we go. Job done. That's quite nice. So in the form a pi, we can say a is equal to 5 over 96, and then b is going to be equal to 9 over 64. So there we go. We've gone through that fairly quickly. The reason I have is because you can see it's an absolute stack of work to do, yet in reality it's not that hard based on you watching the previous 2 videos. But there is a warning that you do need to see the previous 2 videos to have any idea of what's going on there. But that's the idea, and then we've used the idea that we can integrate. We know that we can integrate these multiples of theta rather than trying to integrate. We could, if we knew the reduction formulae, we could have done it that way. But in FP2, reduction formulae is in FP3, so we don't come to it. But there's your answer, 5 pi by 96 plus 9 root 3 over 64. And I assume my workings have been correct.